subtopic is types of chemical reactions. Some of the important types of chemical reactions are: first, combination reactions; second, decomposition reactions; third, displacement reactions; double displacement reactions; fifth one, oxidation and reduction reactions. Let us go one by one. First, combination reactions. Those reactions in which two or more substances combine to form a single substance are called combination reactions. Example: magnesium and oxygen combine when heated to form magnesium oxide. So in this reaction, two elements, magnesium and oxygen, are combining to form a single compound, that is magnesium oxide. So this is a combination reaction. Hydrogen burns in oxygen to form water. This is another example. So in this reaction, two elements, hydrogen and oxygen, are combining to form a single compound, water. So this is an example of combination reaction. Thus, the formation of water from hydrogen and oxygen is a combination reaction. Third example is carbon, that is coal, burns in air to form carbon dioxide. So carbon plus oxygen combines to form carbon dioxide. In this reaction, two elements, carbon and oxygen, are combining together to form a single compound, carbon dioxide. So this is a combination reaction. Please note that when carbon in the form of coal burns in air, then the carbon combines only with the oxygen present in air to form carbon dioxide. Thus, the burning of coal in air is an example of combination reaction. Fourth example, hydrogen combines with chlorine to form hydrogen chloride. Hydrogen chloride is always gaseous in form. Hydrochloric acid is in liquid form. So we have two elements, hydrogen and chlorine, react together to form a single compound, hydrogen chloride gas. So this is an example of combination reaction. This combination reaction is used in industry for the manufacture of hydrochloric acid, hydrogen chloride gas. Hydrochloric acid is nothing but hydrogen chloride gas on dissolving in water forms hydrochloric acid. Hence it is liquid. Fifth example, sodium metal burns in chlorine to form sodium chloride. In this example, two elements, sodium and chlorine, are combining together to form single compound, sodium chloride. So this is a combination reaction. Next example, when iron powder is heated with sulphur, iron sulphide is formed. In this reaction, two elements, iron and sulphur, are reacting together to form iron sulphide, and it is a combination reaction. The next example is formation of calcium hydroxide from calcium oxide. So calcium oxide, that is lime or quicklime, reacts vigorously with water to form calcium hydroxide, that is slaked lime. This is a combination reaction in which two compounds, calcium oxide and water, combine to form calcium hydroxide. A large amount of heat is released when calcium oxide reacts with water to form slaked lime. Slaked lime is a white powder. The substance which we use for whitewashing our house is lime, that is quicklime, which is calcium oxide. We put calcium oxide in a drum. I'm talking about application now. We put calcium oxide in a drum and add water to it slowly. Calcium oxide reacts with water vigorously to form a white solid called calcium hydroxide, that is slaked lime with the evolution of heat. So it is exothermic reaction. More water is then added to get calcium hydroxide solution. The calcium hydroxide solution is then applied to the wall of the house with a brush. So the reaction is as follows. Calcium hydroxide solution, when applied to the wall, reacts slowly with carbon dioxide gas present in air to form a thin, shining layer of calcium carbonate on the walls of the house. Since this process gives a white shiny appearance to the wall of a house, it is called whitewashing. The calcium carbonate is actually formed after 2 to 3 days of whitewashing and gives a shiny finish to the walls. Now this next example is ammonia reacts with hydrogen chloride to form ammonium chloride. In this reaction, two compounds, ammonia and hydrogen chloride, that is gas, combine together to produce a new compound, ammonium chloride. So this is combination reaction. Another example is carbon monoxide reacts with oxygen to form carbon dioxide. So in this reaction, carbon monoxide compound reacts with oxygen element to form new compound, carbon dioxide. So this is combination reaction. Next, sulfur dioxide reacts with oxygen to produce sulfur trioxide. This can be written as, so in this combination reaction, a compound sulfur dioxide combines with an element oxygen to form new compound, that is sulfur trioxide. The next type of reaction is decomposition reactions. Those reactions in which a compound splits up into two or more simpler substances are known as decomposition reactions. The decomposition reactions are carried out by applying heat, light or electricity. Heat, light or electricity provide energy which breaks a compound into two or more simpler compounds. Please note that a decomposition reaction is just the opposite of a combination reaction. So let's see some examples. When calcium carbonate is heated, it decomposes to give calcium oxide and carbon dioxide. So this type of reaction, one substance, calcium carbonate, is breaking up into two simpler substances, calcium oxide and carbon dioxide. So this is a decomposition reaction. When a decomposition reaction is carried out by heating, it is called thermal decomposition. Thermal means relating to heat. The decomposition of calcium carbonate into calcium oxide and carbon dioxide is an example of thermal decomposition because it is carried out by heating. Second example, when potassium chlorate is heated in the presence of magnesium dioxide catalyst, it decomposes to give potassium chloride and oxygen. But this decomposition takes place in the presence of heat and catalyst. So in this decomposition reaction, a single compound, potassium chlorate, is splitting up into two simpler substances, potassium chloride and oxygen. So this decomposition reaction is used for preparing oxygen gas in the laboratory. When ferrous sulphate is heated strongly, it decomposes to form ferric oxide, sulfur dioxide and sulfur trioxide. So as you can see in the chemical reaction mentioned, the green color of ferrous sulphate changes to brown due to formation of ferric oxide. Ferric oxide is also known as iron trioxide. Now the ferrous sulphate crystals which are available in a science laboratory are actually ferrous sulphate heptahydrate, that is FeSO4, hepta means 7, so 7, hydrate means water, H2O. So FeSO4.7H2O. They contain 7 molecules of water of crystallization. These crystals are green in color. Note that when the green colored ferrous sulphate heptahydrate crystals are heated, they first lose 7 molecules of water of crystallization to form anhydrous ferrous sulphate, which is white in color, and then this anhydrous ferrous sulphate decomposes to give ferric oxide, sulfur dioxide and sulfur trioxide. When lead nitrate is heated strongly, it breaks down to form simpler substances like lead, monoxide, nitrogen dioxide and oxygen. So in this decomposition reaction, the colorless compound lead nitrate forms a yellow compound, lead monoxide, and brown fumes of nitrogen dioxide gas are evolved. Since the decomposition of lead nitrate is brought about by heat, Therefore, it is actually an example of thermal decomposition. Next example, when electric current is passed through acidified water, it decomposes to give hydrogen gas and oxygen gas. This reaction can be represented as follows. So in this decomposition reaction, a single compound water splits up to form two simpler substances, hydrogen and oxygen. This decomposition takes place by the action of electricity. Note that it is called electrolysis of water. Note this. Next example, when electric current is passed through molten sodium chloride, it decomposes to give sodium metal and chlorine gas. This decomposition reaction is used to obtain sodium metal from sodium chloride common salt. It is called electrolysis of molten sodium chloride. Note this. Next example, when electric current is passed through molten aluminium oxide, it decomposes to give aluminium metal and oxygen gas. This decomposition reaction is used to extract aluminium metal from aluminium oxide. It is called electrolysis of molten aluminium oxide. We will now describe some decomposition reactions which are brought about by light energy. When silver chloride is exposed to light, it decomposes to form silver metal and chlorine. So, in this reaction, the white color of silver chloride changes to grayish white due to the formation of silver metal. The decomposition of silver chloride is caused by light. It may be sunlight or bulb light. So, this reaction is used in black and white photography. Silver bromide also behaves in the same way as silver chloride with light energy. Thus, when silver bromide is exposed to light, it decomposes to form silver metal and bromine vapors. In this reaction, pale yellow color of silver bromide changes to greenish white due to the formation of silver metal. The decomposition of silver bromide is caused by light. The light may be sunlight or bulb. This reaction of decomposition of silver bromide is also used in black and white photography. Now, what are the uses of decomposition reactions? The decomposition reactions carried out by electricity are used to extract several metals from their naturally occurring compounds like chlorides or oxides. When the fused, that is molten metal chloride or metal oxide is decomposed by passing electricity, then metal is produced at the cathode. Cathode is negative electrode. For example, sodium metal is extracted by electrolysis of molten sodium chloride, whereas aluminium metal is extracted by the electrolysis of molten aluminium oxide. Decomposition reaction in our body. So what is this? The digestion of food in the body is an example of decomposition reaction. When we eat foods like wheat, rice, potatoes, then the starch present in them decomposes to give simple sugars like glucose in the body, and the proteins decompose to form amino acids.